Hello, math friends. It's great to have you here today. We're going to simplify multi-step problems. It's Mr. Mackin in the background giving us a little shout out. When we solve problems that are multi-step with exponents, we have to make sure that we pay super close attention to the directions. Here it says write the following as a fraction with no exponents. They want us to get the exponents out, which is not a problem. So we're going to go ahead and get started. We have two bases that are like, they're both 4, and we're multiplying. So that's going to mean that we're going to add our exponents. So we're going to have 4 to the 2 plus negative 4. And 2 plus negative 4 is going to give us 4 to the negative second power, which would be super great, but we're supposed to get it into a fraction with no exponents. I remember that when I have negative exponents, I can write it as a fraction with a 1 in the numerator. So I have 1 over 4 to the second, which is going to get rid of the negative. And then I'm almost there, but I got to get rid of my exponent, which is no problem at all because I know that 4 to the second power is just 4 times 4 or 16. And there is my beautiful answer that satisfies my directions. All right, that's pretty good. It's a real nice start. Let's try another one. Okay, so this time my directions are just to simplify. I know I'm not going to be able to get it to one number answer because I have x's in here and I have y's. And when I have variables, it's probably not going to simplify all the way down to one number, but you never know. So let's go ahead and get started. It's a bunch of divisions, so we're going to start by doing the division of our whole numbers. If I do the division of our whole numbers, I have 12 divided by 4, which is going to give me a 3. I could also think of it as 3 over 1 if I want to make it a little easier for myself in trying to make sure that I keep the fraction if I need it. The next part that I'm going to do is my x's. So I have x to the 6 divided by x to the 12. I can go to the side and remember that when I'm doing division, I'm going to subtract. So it's x to the 6 minus 12. And 6 minus 12 is negative 6. Or I could think about it as 1 over x to the 6, which would tell me that my 1 would go on top and my x to the 6 would go on the bottom. And now I'm ready to move on to my last pair. And my last pair is y to the 4th, y to the 3rd. And they're a pair because they have the same variable. So I can think about that as y to the 4 minus 3. And 4 minus 3 is equal to y to the 1, which anything to the first power is just that same old thing. So it's just y. Or I can think about it as y over 1 if I want to make it easier when I'm filling it in here. Now really all these ones, when you multiply by 1, you just get the same number. So if I simplify it out without my 1s, I'm going to get 3y over x to the 6th power. And there's my totally simplified, super fantastic, smile warranted answer. Woo! All right, let's try one more here. Okay, this one's different because we have an exponent on the outside of our parentheses that we're actually going to have to distribute through to all of our different pieces of our problem. Every single number has to get it. So if I rewrite, I'm going to get 2 to the 3rd times 3 to the, I multiply my exponents when it's on the outside like that, 3 to the 6th over 3 to the 4th, and I got to do 4 times 3, which is going to give me 3 to the 12th. That looks pretty good. I did a great job of distributing that 3 through, but now I have like bases right here and a division, so I can go ahead and subtract. I'm going to go off to the side and think about that as 3 to the 6 minus 12, which I could chop it and think about it as 3 to the negative 6. So 3 to the negative 6 could be the same as 2 to the 3rd over, because 3 to the negative 6 is the same as 1 over 3 to the 6, so it's just going to go in my denominator, 3 to the 6th power. Now in this case, 3 to the 6th gets pretty big, so most of the time you can probably just leave it in exponent form because we'd have to pull out a calculator probably to do 3 to the 6th. And so we'll leave it alone. You could get it to your whole number answer since they're both just whole numbers to exponents, but I think in this case that looks pretty nice and neat and super fabulous. It totally makes me say, wow, you are a great mathematician. So that's it for how you are able to simplify multi-step problems with exponents. Have an awesome day.